Okay, in this video we're going to be talking about functions. Some of the vocabulary before we start. A relation is any set of ordered pairs or connecting an input to an output. A function is a relation for which each x has only one y with it. Each first coordinate has exactly one second coordinate. Function notation is just the notation used in f of x. So it's read as f of x, and f of x is equivalent to y, which means they're pretty much interchangeable. X is the independent variable where f of x is dependent. And lastly, the vertical line test is a way to check if a function that has been graphed is a relation that has been graphed is a function. If the vertical line crosses the graph of the relation in more than one point, the relation is not a function. So if we look at these first three examples, for the first relation right here, this one is a function. Since the x values do not repeat, we know that it must be a one-to-one function, which means each x only has one y. In this one here, let's see, the x values do not repeat, so again, this is a function. A lot of people will make the mistake and look at the y values. Notice that the y values are repeating, but it doesn't matter because each x only has one y counterpart. The y's, they can have as many x's with them as they want. And lastly, for this graph, do the vertical line test. Notice no matter what vertical line I draw, it touches the graph only one time. Therefore, it's a function. That was it for example 1. Example 2 is using the graph to evaluate the function. So f of 0 means that x value is 0. The number inside the parentheses is an x value. So if you're given the x value, respond with the y value. So here's the x value of 0. I'm going to go down to the graph. That y value right there is -2. If I continue to the next one, f of 1, the x value is 1. That's right here. Go up to the graph. That y value is 1. F of 2, the x value now is 2. Right here. And then we're going to go up to the graph. That y value is 2. And lastly, we have the f of -0.5. So f of -0.5 should be somewhere about there. I'm going to go down to my graph. That's not a very straight line. Try to make it straight. It looks to be about -4. That is example 2. Example 3. We're supposed to find the value of f of -1 if f of x equals -x cubed minus 1. Notice the difference between this and this. The difference is that this one has a -1 while this one has an x. So we're going to take out the x and we're going to replace it with -1. So f of -1 would equal -1 to the third minus 1. And now I'm just going to go through and simplify. -1 to the third is still -1. We carry everything else down. This double negative right here will make a positive. So it's going to be 1 minus 1 that comes down. And 1 minus 1 is 0. So f of -1 is 0. That's not a very good 0. There we go. Next one, number 4. Notice that this one is different. You will see that f of x is the same for both. I guess I should read the whole problem. Example 4 is, what is the value of x when f of x is equal to 18 if f of x is 3x minus 9? And again, notice both of them have f of x equal to two different things. Well, if f of x equals 18 and f of x also equals 3x minus 9, then 18 has to equal 3x minus 9. Now it's just a matter of solving for x so we can answer the question. Add 9 to both sides. And then divide by 3. Giving us that x is 9. Okay, the next problem is a word problem using function notation. The function s of t is equal to negative 4.9 t squared plus 20 models the height of a penny dropped from a 20 meter high platform after t seconds. What is the height of the penny after 1.5 seconds? The trick to figure out doing this one is to figure out whether the 1.5 should be plugged in for t or the equation should be set equal to 1.5. For this one, it says t seconds, which means t is the time there. So 1.5 is t. So we're going to be trying to find s of 1.5. So we get negative 4.9 times 1.5 squared plus 20. This one I'm probably just going to type in the calculator and get the answer instead of working out algebraically, just because of the decimals involved in this problem. Okay, I typed it in and got an answer. Notice I didn't write the 0 for the 20. I did fix that. After typing in the calculator, I got that s of 1.5 is equal to 8.975. The units here would be meters. So there we go. Okay, the last example is another substitution one. If we read it here, find and simplify f of a minus 5 if f of x equals x squared plus 4. Notice again that the difference between these two is that this one on the right has an x there, and what we're trying to find is f of a minus 5. So we're replacing x with a minus 5. So for f of a minus 5, we are going to take out x. So I'm going to leave myself blank parentheses. Squared plus 4. And what's going to go in that parentheses? Well, we're substituting in a minus 5. Now it's just a matter of going through order of operations and simplifying this expression. Normally we would try to do anything in parentheses, but we can't really do that. We can't combine a and 5. So I'm going to deal with exponents next, which means I have to distribute this out. Remember that because there is a minus sign in here, you can't just give that exponent of 2 to each individual thing. Addition and subtraction means that exponent properties are not valid. So, next, so I'll write this out twice, a minus 5 and a minus 5, and I will distribute it out. So we got a squared minus 5a minus 5a plus 25. If I combine that, I get a squared minus 10a plus 25. I'm going to carry my 4 down now. A lot of the times when I do this distribution, I'll write it off to the side and do it off to the side. This way my problem is not as jumbled. Lastly, I'm going to try to combine a addition subtraction. So a squared minus 10a, and then these two are like terms, so plus 29. So we get that f of a minus 5 is equal to a squared minus 10a plus 29.